All right, in this video, we're going to talk about how to graph a very basic quadratic function. So the first thing we want to talk about is what is a quadratic function. In the last chapter, we went through equations that had this form ax squared plus bx plus c, and then we worked on things such as factoring. Now, the graph of this thing is called a parabola, and it's a U-shaped graph that we see here in the picture. And there's some characteristics here that we need to understand so that when we discuss what's happening with graphs, we have a common language, a common vocabulary. So first thing is the vertex. That's where the graph is going to change direction, right? And at the vertex, there's also what's called the line of symmetry, where the graph is split into a symmetrical half. Now, on one side of the parabola, the graph will decrease until it hits the vertex, and then it will increase on the other side, right? So this function, f of x equals f squared, is the parent function of quadratic equations. All right, we went through those examples here. All right, so in this case, we have a graph, and we notice that the vertex went from 0, 0, and it shifted left 1 and down 2. So the vertex now is at the point -1, -2. The axis of symmetry is going to be whatever the x coordinate is. So in this case, the line x equals -1 is the axis of symmetry. This is a vertical line that was discussed in prior lessons. All right, in this case, the function decreases all the way until x equals -1, and then it will increase when x is greater than -1. We need to talk about domain and range. For quadratic functions, domain would be all real numbers. The range is the values greater than or equal to -2. In this case, the range is written in words. We could also write it as an inequality. The increase and decrease value are shown here as well. So these are the characteristics we want to talk about when it comes to analyzing quadratic functions. All right, now what happens when a is greater than 0? So in the prior example, a was equal to 1. Now in this case, a will not be equal to 1. It'll be greater than 0. So what happens is we end up graphing using a table, and we get a nice graph here. So this right here is 2x squared, the function 2x squared. So if we take our x value -2 and we square it, that gives us 4, and then multiply it by 2, that would give us a value of 8. We would continue that all the way through, and we would get our ordered pairs. And we see that the graph decreases in value. It goes from 8 to 2 to 0. And then it goes from 0 to 2 to 8. So we see that it's decreasing to 0 and then increasing to +8. All right, now if we look here on the graph, now you see a second curve, and this is the parent function of the function x squared. And we notice that when the a value is greater than 2, the curve gets very, very steep. It increases much more quickly. Okay. These characteristics are very similar to what we saw in absolute value functions as well. Okay. Now, the vertex of both graphs would be 0, 0. They would both have the same axis of symmetry. The difference is that the function 2x squared would be narrower, right? And this is what we call a vertical stretch. So the word vertical stretch we've seen in the past, and it becomes an important term now. That means that we're stretching this thing vertically, which means it's getting big very quickly. Okay. All right, now here's a case where a is less than 0. So now we're talking about values that would be fractional or negative. All right, so we see both examples here. So in the past, the negative would reflect the graph over the x-axis. Okay, and that's what we see here when we plot the ordered pairs. We see that the graph is now pointed downwards, and that's due to the negative sign. Now, we also see that the a value is 1/3. So what happens here is we get a flattening out, and this is what we call a vertical shrink. So if you look down towards the bottom, it's shrinking by a factor of 1/3. The factor is whatever the a value is. So on the prior example, we had a factor of 2. That was a vertical stretch. In this case, we have a shrink by a factor of 1/3. The negative has nothing to do with the shrink. It has to do with the reflection. So the negative sign is the reflection. The 1/3 is the shrink.